Bismillahirrahmanirrahim. So today our topic is about the spin splitting in the NMR spectroscopy. ये NMR spectroscopy का one of the important topics है and इसमें in every exam चाहे वो lecturership का हो चाहे वो graduation post graduation का हो या कोई भी exam हो नेट का उस पे question आता है और structural determine करने के लिए ये बहुत ही important है. But anyway यहाँ पे as we know that we are actually looking to go into the we are designing our topics for the objective type exam. तो ये spin splitting को understand करने के लिए again हम back जाते हैं हमारे compound पे. हमारा एक compound है for example this is ethyl bromide CH3CH2 this. अब ethyl bromide में हमें कितने peaks आएंगे अभी तक जो हमने पढ़ा था. अब कितने peak आएंगे that depends on how many types of protons are there. This is one type of proton क्योंकि इसका chemical environment different है. This is another type. So that's why I have labeled it 1 at B. फिर मैंने कहा था A हम उसको लेबल करते हैं which is highly dishielded. Fine. Now this is dishielded because it is attached to electron withdrawing group. That means these protons they have higher chemical shift value. So the value is A. And this is low chemical shift value, so the value is B. Now if we go to the NMR scale, so we will find it around this region, aliphatic region. So 2 पे हमारी peak आती है. This peak corresponds to our sorry थोड़ा सा mistake हुआ यहाँ पे. This just build it again. So this is basically because ये वाला this is higher chemical shift value, so A will come here. So we have the case like so this is our higher chemical shift value that is around 4. तो 4 पे ये वाला आ जाएगा that is this CH2. So it is so we get a signal like this. And then we have here signal 3 proton signal. So this is our NMR. Normal NMR will get this is our now B, that is CH3 proton of methyl bromide. This is A. So this is our normal NMR. So far जो हमने पढ़ा कि we should get like this. लेकिन ऐसा होता नहीं. When you see the NMRs nowadays, you'll see earlier days में now we have high magnetic field, very developed NMRs जाते हैं FTR based. तो हमारा ऐसा आता है now we are getting this peaks like they are splitting now. अगर हम back जाएंगे यहाँ से you see this has splitted into this 1 2 3 peaks and this peak has splitted into 1 2 3 4 peaks. Now why is this splitting? So that's why we have a topic that is the spin coupling, this coupling, and this is also called as spin splitting. ऐसा क्यों होता है? In order to understand that we'll go back to our compound. So why it happens? So we have CH. So we have H here. Then this is adjacent proton. We'll make one more H here. This is our ethyl bromide. So this is our ethyl bromide. Now first of all, इसमें there are 2 sets of protons. That means this set of proton 2 and these set of proton they're different. तो हमने पहले भी कहा we say they are chemically non-equivalent. They are chemically non-equivalent. Whenever we have chemically non-equivalent protons, then only this splitting is important. Remember, तभी ये splitting occur हो जाएगा. So super splitting occurs when we have 2 adjacent protons, 2 adjacent non-equivalent protons, chemically non-equivalent protons. So this is condition, equivalent protons. So adjacent carbons, adjacent means that this carbon followed with this carbon. So we have proton which is different, we have proton which is different. So spin splitting occurs in the peaks only when we have chemically non-equivalent, chemically different protons on the adjacent carbons. Then the phenomena of spin splitting occurs. Now, अब यहाँ question है जैसे मैंने इस example को लिया why we have 3 peaks here splitted, this peak into 3. So this peak has splitted into 3. So this peak has splitted into 4. और एक चीज अब यहाँ भी थोड़ा देख ले कि इनका पैटर्न बहुत जबरदस्त है. देखिए इसका हाइट ये वाली हाइट ट्वाइस तो इसका जो हाइट पैटर्न जो है दैट इज 1:2. इसका 2 टाइम्स हाइट है इसका. अगर इसकी हाइट 1 मान ले इसका भी 1 तो 2 होगा. इसका भी देखिए सिमेट्रिकल पैटर्न, इसका अगर हम हाइट 1 मान ली, फाइन, तो इट इज ऑलमोस्ट 3 टाइम्स, थोड़ा सा, सो इट्स 3 टाइम्स, इट्स ऑल्सो 3 टाइम्स देयर इक्वल हाइट, इसको अगर मान लिया, सो इट्स ऑलमोस्ट 3 टाइम्स इनकी हाइट, थोड़ा कम हो सकता है बट वो ड्राइंग में थोड़ा सा डिफरेंस हुआ है, और ये 1, तो इनका पैटर्न भी है। तो दो चीजें हमें अंडरस्टैंड करनी है, व्हाई देयर इज स्प्लिटिंग एंड व्हाई देयर इज दिस टाइप ऑफ पैटर्न। सो नाउ विल गो बैक टू आवर मॉलिक्यूल। यहां हम देख ले कि why this occurs. Now these 3 protons, they are different type, they have a different chemical environment, so they are chemically non-equivalent. So this is these 3 and these 2, they are chemically non-equivalent, but within this carbon they are equivalent, within this they are equivalent. So understand करने के we'll take example of this proton and this proton only. ऐसा इसलिए होता है, we know this is the proton and we are talking about NMR spectroscopy, it has a magnetic spin, so it has some magnetic field. And then we have on this bond electrons. So those electrons also they have, we know charged particles, but they have the magnetic field. So we पढ़ा था shielding case में, shielding case में. So this magnetic field of this or the magnetic vector of this proton, it attracts the magnetic vector of this electron. अब चूंकि it is in turn bonded with this electron, so that gets transmitted. So magnetic effect of this vector, that gets transmitted to this bond. Now is carbon में then we have one more electron on this side, so this in turn gets transmitted up to this, and the magnetic effect of this magnetic field इसका that is has some the influence here, now which in turn influences this electron, and finally through these bonds this magnetic field of this proton gets affected. Same is the case, the magnetic field of this proton, it affects the magnetic field of this proton. So these 2 protons, they are interacting between them, but remember this interaction is not through space, remember, very important. There's a different topic where the interaction occurs through the space, but here in the spin-spin splitting, this interaction is not through space, rather this and this proton, the magnetic fields of this and this proton, they interact through the intervening electrons. So spin-spin splitting basically occurs when we have 2 adjacent protons which are non-equivalent. So the splitting occurs due to it occurs through intervening electrons between the two, or electrons से आप bonds भी ले सकते हो, intervening bonds between the 2 protons which are non-equivalent, between 2 hydrogen atoms which are non-equivalent. It's like we have here this and this. Now we know that the splitting is due to the magnetic field of 2 non-equivalent protons and the adjacent carbons. This type of, and so we have 3 bonds between 1, 2 and 3. और 3 से आगे कभी होती नहीं, बहुत एक्सेप्शनल केसेस है जहां पाई बॉन्ड्स आते हैं बीच में, इन दैट केस इट गोज बियॉन्ड 3. तो नॉर्मली दिस इज एक्चुअली इट इज बिटवीन व्हेन वी हैव 3 bonds between this and this proton. This type of pattern splitting occurs. Now, so we have a splitting. Now question is how the splitting will occur. So we have a question, if you have to split this peak proton, the peak of this proton, it depends on how many protons are on the adjacent carbons. So I can write that the splitting of given set of protons, so there's a rule that the splitting of given set of protons that actually depends on how many protons are on the adjacent carbon. So it depends on the protons, the number of protons on adjacent carbon, so जितने इस पे adjacent, let us see, इस adjacent पे 2 है, so that this proton signal will split into, so this proton यानी इन तीनों की जो सिग्नल है that will split into n+1. तो n means number of protons on the adjacent पे 2 है, so this signal will split into 2 + 1, that is into 3 peaks. That is why this B splits into 1, 2 and 3. Same is the case. इनकी सिग्नल कितनों में स्प्लिट हो जाएगा, दैट डिपेंड्स ऑन हाउ मेनी प्रोटॉन्स ऑन द एडजेसेंट पे 3 है, सो 3 + 1 n+1 रूल, सो दैट मींस दिस इज 4. That is why this A splits into 1, 2, 3, 4. So this is the basically simplest formula, that into how many peaks a given proton signal will split, that depends on how many protons are on the adjacent carbon. And this formula you can actually calculate. Fine, for number of molecules. We'll do this in some next class. We'll take some molecules and we'll try to do this pattern. Now, our question is now, so question number 1, so into how many peaks a signal will split, that depends on how many protons are on the adjacent peak. The formula is n+1. उसके बाद ये पैटर्न, ना तो पैटर्न किस तरह से आता है? So as far as the pattern is concerned, so the splitting pattern depends. Splitting pattern, it follows, we can say it corresponds to numerical coefficient. It corresponds to numerical coefficient of lines in, of signals or lines in binomial expression. ये बहुत important है. Binomial expression जो mathematics में होता है, binomial expression. That means so binomial expression, we have this. So it's 1 plus x raised to the power n. See? So 1 plus x raised to the power of n, we write it. So this is equivalent to 1 plus, this is equivalent, if we get this, n is equal to 1, so that's 1 plus x. So if n is equal to 1, this is 1 plus x. So for n is equal to 1 now. If you give n the value 2, so for n is equal to, that is equal to 1 plus x, that's 1 plus 2x plus x square. Likely, if n is equal to 3, this is 1 plus, that's 1 plus, this is 3, that's 3x square. 3x square plus 3x plus x cube, and so on. So the splitting pattern that actually follows this binomial expression. So देखिए यहाँ पे it's 1, so take the coefficients of this 1, 2 and 1. So that means अगर आपके पास जो है 3 lines है किसी spectrum splitting will be as per 1:2:1. इसका 1, that's coefficients of the binomial expression मैंने कहा था. So they will split as per the numerical coefficients of the signals in the binomial expression. So if we have 3 peaks, 1, 2, 1. If you have 4 peaks, 1, 3, 3, 1. So the pattern लॉ करते हैं जहाँ पे 3 peaks है, so 3 peaks के लिए ये वाला formula 1:2:1. So the height of the peaks will be 1:2:1. यहाँ पे 4 है, so 1:3:3:1. Now अगर ये formula, because sometimes we don't have the people which actually have some mathematics, हमारे लिए एक बहुत easy way है, that is the Pascal triangle. So the splitting will occur as per the Pascal triangle. ये बहुत ही आसान है. You not to worry about if you don't understand the binomial expression. So the splitting occurs as per the Pascal triangle. So Pascal triangle हम याद रखेंगे ऐसे. So we'll keep here 1. Here we'll keep 1:1. Then we'll keep 1:2:1. Okay. So then we'll keep 1:, this is 2 plus 1, 3. 2 plus 1, 3. And this is 1. And then you can further increase depends on कितने peaks होंगे. This is 4. This is 6. This is 4. And this is 1. तो इस तरह से you can build a triangle. Fine. तो इसका मतलब अगर आपका एक ही पीक है तो इसका एक ही है. अगर 2 peaks split into 2 peaks, height will be 1:1. अगर आपकी signal split into 3 peaks, height will be 1:2:1. If your signal splits into 1, 2, 3, 4 peaks, height will be 1:3:3:1. Now if your signal splits into 5 peaks, height will be 1:4:6:4:1. Now when it splits into, जब एक ही peak है, it's called as, इसमें हम spectroscopy में use करते हैं singlet. If it's split into 2 peaks, we say it's a doublet now. If a peak splits into 3 peaks, we say it is a triplet. And if a peak splits into 4, we say it is a quartet in the spectroscopy language. And if it splits into 1, 2, 3, 4, 5, we say it is quintet and so on. Quintet. But your higher values are usually we say multiplet. Usually 3, 4 se aage we'll start saying that it's a multiplet. So this is all about the basics. जो हमें इस level पे आएगा, the basics of the spin splitting. It occurs basically that our NMR splits into peaks. That only occurs when you have two non-equivalent protons on the adjacent carbons, and so the splitting occurs depending on how many protons are on the adjacent carbon. For example, in this case we have 3 protons, that means this will split into 3 plus 1, that's 4, and this will split into 2 plus 1, that's 3, and then the splitting pattern is given by the Pascal triangle, and we have the name is accordingly singlet, doublet, triplet, quartet. This is all for the day. So tomorrow inshallah we'll do some questions on this, some examples, so we'll understand it better. This is enough for the day.